Hello, everybody, and welcome to PyCon Sweden 2021. And this will be the second presentation today of the software track. My name is Erasmus, and I'll be your moderator this session. Here, Sanskar will be presenting. Sanskar is a software engineer working at Bloomberg, London, and he will be presenting Robyn, which is a synchronous Python web framework with a Rust runtime. Welcome, Sanskar.
Thank you for the warm introduction, Erasmus.
The floor is yours.
Thank you. Right. Hi, everyone. My name is Sanskar, and today we'll be talking about Robyn, which is an async Python web framework with a Rust runtime. Before we begin, a brief about me. My name is Sanskar. I work as a software engineer at Bloomberg. I just turned 22, and I'm an Indian who just moved to the UK. And apart from that, I run an open source organization called Mexili. And after having a deep passion towards software engineering, apart from that, I have a very big affection towards dogs. And I can scroll at dog photos throughout the day without having any remorse at all. So before we begin our presentation, here are a few pictures of my dog to bless this presentation. So, all right, what is Robyn to begin with? In short, Robyn is a fast async Python web framework with a Rust runtime. That's it. So Robyn is currently hosted on GitHub. It follows a BSD 2.2 clause, and the latest release is 0.7.0. It has around 200 stars on GitHub, around 50K downloads on PyAPI, and importantly, it is under active development. So some of the key features that Robyn boasts is it is under very active development. And another very important feature that it has is that it is not written in just another languages. It is written in Rust, by the way. It has a multi-threaded runtime. It is extensible. So you can build a lot of plugins over Robyn. So you can extend it as per you require. It has a very simple API. So there is almost no learning curve involved if you have experienced with other Python frameworks. It is fast, like very fast, because it can serve around 10,000 requests in 1.8 seconds, even on a dual core machine. It supports async. It has multi-threaded file and directory serving, dynamic URL routing. But most importantly, it is a community-first framework, and I truly believe in free and open source culture for it. Okay, so now comes the juicy part. Like, what is the Robyn story? What was my motivation behind creating Robyn? So it was April of 2021, and I was still in my university. Our final project deadline was approaching, and like any hardworking student, I was spending all my time scrolling Reddit. So around that time, a big company decided to bring Rust into one of their projects. And Reddit was filled with this major trend. Like this big company decided to include Rust in one of the kernels. So this was the major trend that was happening in Reddit, rewriting everything in Rust. And at the same time, since I was such a hardworking student, I was working on an unrelated project called EncryptText. And this had a Flask backend. I have been a Python developer for like the past four years or 5 years, and Flask has been my go-to framework of choice whenever I write Python. But there's always one thing that I disliked about Flask, or that annoyed me about Flask, was that async model didn't exist. Since I used to write Node and React from time to time, writing code in an async model was really something that I enjoyed. I had used Quartz and Fast API at the time, but since these were not very mainstream, I didn't adopt them in my own development practice. So I told myself, Sanskar, what would be cool if you could create Flask with async support? Then I told myself, what would be cooler if you could write it in Rust, by the way. Since I realized that Ryan Dahl was able to create Node in C++, and he was able to write a lot of runtime of Dino in Rust. So Rust may not be a bad idea after all. Okay. So let's have a look at a traditional Python app lifecycle, or how do you actually deploy a Python web framework in a traditional way. In the front, you have a reverse proxy that routes all the requests coming to the server. to the web server. And in the middle, you have a web server that is either a WSGI or an ASCII server. And towards the end, you have web frameworks like Flask, Django, Fast API, and so on. So let's have a look at the web framework aspect of it right now. Traditionally, a Flask app looks like this. And since I'm really inspired by Flask and I really like the way you could model the app in the Flask framework, Robyn takes a lot of inspiration from the Flask API. It has some distinguished features that I feel would make the API better and make it more convenient to program, but it has almost no learning curve involved if you have some Flask experience. So this is how a Flask app looks. You import the Flask class from the Flask package, you instantiate it, you create the decorator routes, and you add the function. That's it. And same goes for a Robyn app. You import the Robyn class, you instantiate it, you create some routes, you create the same routes for the sync as well as the async functions, and you can start the app. Now let's come to the web server aspect of a Python application. In general, these web servers are WSGI or an ASCII server. So in front of me, you can see the code snippet of a WSGI server. WSGI server and the ASCII servers were created for a very specific reason. Earlier, there were like many web frameworks in Python, like Zope, Quixote, Twisted, and so on. But they didn't actually have a standardized way to deploying the application. So with the variety of web frameworks, this was inspired from Java, where the Java servlets were available in variety, but you could still use any server to deploy them. So what it basically does, WSGI is basically gives you your application a single callable. So you just need to make your app compatible with the one function, and it handles all the dirty things for you. You don't need to worry about managing the HTTP headers. You don't need to worry about managing the requests. All you need to focus is more on the router side and more on the execution of function side. And ASCII or an ASGI is also a very similar thing to WSGI. It allows async support, but it has a little differences, but it's very similar overall. So a WSGI or an ASCII, if you want to read more about it, you can check the PEP 333 documentation and you will have more information about WSGI servers or WSGI servers. But even though since they are so good and they allow such like a stress-free experience for the developer, Robyn requires no SGI. This is also one of the reasons why Robyn is faster than other frameworks. One of the reasons is that all the WSGIs and the ASGIs are written in Python. And since we require speed, and the main focus of Robyn was like on the execution speed, Robyn comes with a coupled web server. So you do not require any external web server or any external ASCII or WSGI to ship a Robyn app. So this is how the architecture of Robyn looks. You just need to have a reverse proxy in front of your server, and Robyn is coupled with the web framework, web server, and a framework. So even if you write the command python 3 app.py, the app will run without an issue, and it will run in a production mode as well. So yeah, now let's have a look at the architecture to have a sense of what actually is happening and how this all is actually that fast compared to other frameworks. Firstly, let's focus on the leftmost side. We have a worker event cycle that basically does all the dirty work for you, manages the runtime, it passes all the instruction to the Rust code, it directs all the requests to the router, and so on. Now let's have a look at the topmost right side. We have the Python code that is converted to the Rust object. When the worker event cycle creates the runtime, it deploys the thread pool. And this Python code is converted to Rust code. For example, when you write the code app.get and you create a route, you write a function below it. So this Python object is converted to the Rust objects. And then these Rust objects are mapped in a multi-threaded router. So for every incoming route, these objects are mapped to the corresponding route. So now the incoming requests are directed to the worker event cycle, which then directs them to the router. Now this router finds the corresponding execution object and dispatches them in a thread pool. Since it is much faster because the router is also multi-threaded, as well as the execution runtime is also multi-threaded. So this is one way on how we can bypass some part of the GIL or the global interpreted lock, which is nefarious for having slow execution and not providing true multi-threaded experience. And after the work is completed, all the completed tasks are dispatched back to the event cycle, which dispatches back the result. And this is how the execution of Robyn takes place. All right. And if you are not already excited, we have a little feature showcase to get you all excited. First of all, Robyn supports sync function as well. Many people tend to believe that async function is just a mental model and it doesn't provide any actual benefit for it. So that's probably the reason why these many libraries have no async support, or there are many libraries that exist in the world that only provide sync support. So that's the reason why Robyn supports synchronous functions. And the good part about this is that these synchronous functions are executed in their own individual threads. So if you just write sync code, and even if you block one thread, there's a high chance that some other thread will be free. So you can still have a concurrent feel to your application. And one of the core reasons behind Robyn's origin was an async function support. You can use the same decorators, and these async functions will be deployed in their own thread pools. And you just need to add the keyword async and change your code accordingly. You can use the same decorator to deploy the app. And as I told you, I'm also a front-end developer, and it always used to annoy me that there was no easy way to deploy a React application or a Vue application in a Python backend code. It was very easy to deploy a subroute with a Python app of a React build or a Vue build in an Express application or in any basically TypeScript or JavaScript backend framework. But it was not very simple to do that in a Python framework. That's the reason why I created this. So you can have any subroute. You just need to mount the directory, and you need to specify the individual, like the index file, and you are basically good to go. You can even mount the entire application on a single route, or you can mount multiple applications on separate routes as well. Now we also support static file serving, and this static file serving is much faster than the existing static file serving that are present in the other web frameworks. One of the reasons is that it uses native Rust IO and not the traditional Python IO. There exists a possibility that one day in the future this will also be a multi-threaded file serving, but even if that doesn't take place, the native Rust IO has been proven much faster than the existing Python IO. So we can now serve lot more files when you use Robyn as compared to other frameworks. We also support dynamic URL routing, so you can just use a colon and the variable name, and you can access these parameters through the request object that is provided in every method of the every method below every route. Okay. And if you're still not excited, we can have a look at the performance comparison stats. Also, a PSA that this comparison is not to demean any framework or the people associated with the projects. These projects were the reasons why I was so excited and why I actually like Python, but the names are used only just to get a more clear understanding and to have more perspective. So we were using Flask. We compared Flask, Fast API, Django, and Robyn. Flask was used with GUnicorn, Fast API was used with Ubicorn, and Django was also used with GUnicorn. And all of them were provided 5 workers as recommended on the website. So we were serving this test was done to serve 10,000 requests. And it took around 5 seconds for Flask to serve 10,000 requests, which was around 1,800 requests a second. For Fast API, it was 4 seconds, and it was like 2,400 requests per second. For Django, it took around 13 seconds and 740 requests a second. For Robyn, it took like 1.8 seconds and around 5,400 requests a second. These numbers are not absolute by any means. These were done on my own local machine, which is a dual core MacBook. So these numbers can vary depending on your machine, but still it gives like a right perspective of the relative speeds of each framework. Now, before we come to the final parts of this talk, I would just like to document the journey of Robyn so far. In April, I got the idea on creating a framework. In May, the first commit was pushed. After that, I started getting my hands dirty in Rust, learning production level Rust and learning more about the language. And by June 21, we integrated an async support and had a Rust runtime. In July 2021, we improved the runtime performance and added some basic features like serving get requests, post requests. In August to September, it is actually the time when I moved to London. So development was a little slower here, but we still managed to make it HTTP compliant, add dynamic routes. So Robyn at the moment is completely compliant to HTTP 1.1. And for the future, we plan to improve the scale across multiple cores. What we plan to do is to share the TCP socket across all the different cores that are available in your machine. The PR is open. I just need to do a final few testing, and then hopefully we can have it in the next release. I plan to add WebSocket support HTTP streams, and possibly add GraphQL integration in the future. So this is the roadmap of the future. And most importantly, I also plan to create a logo for the application, logo for the framework. So I do have a logo in mind, but if you have any suggestions, feel free to open an issue request or anything. So thank you. That's all from me. Here you can see the links of the presentation here. Robyn is hosted on GitHub, on PyAPI. The website of Robyn is mentioned here, and here is a doc link. We do also have a Jethi community of Robyn. And if you have any questions regarding Robyn, you can just post it on the Jethi community. I'm fairly active, and there are also other few folks who are very active in the community. And if you have any other questions apart from Robyn, you can either DM me on Twitter or you can send me an email. All my details are mentioned here. And if you ever want to submit any feedback to Robyn, or if you would like to discuss anything about Robyn in general, feel free to open an issue. If you'd like to suggest an improvement, just open a PR, send me a DM. I'm very active on these platforms. So thank you, everyone, and I hope you enjoyed the talk.
Thank you very much, Sanskar. It was very interesting. We don't have any questions currently, but we could perhaps wait just a couple of seconds for people to have the possibility to ask questions if they have any. Sure. So let me just ask you a question here, since there aren't any. Are you the sole developer of Robyn?
Yes. At the moment, I'm the only person who maintains and creates Robyn.
Okay, that's very impressive, I have to say. I mean, seeing the timeline there.
Thank you so much. I do hope that after this presentation, many people will be excited and will start contributing to the project.
So, are you just doing this on your spare time?
Yes. But like due to the quarantine, we had a lot of spare time in the university. So I was doing then. Now it's actually like a side project and on the weekends. Thank you, Helio.
Great talk. Okay. So if we don't have any questions, then I'll just say thank you so much, Sanskar. This was very interesting, and I'll make sure to try out Robyn myself.
Perfect. Thank you so much.
Thank you so much, everyone.
Thank you, Rasmus, and thank you for the PyCon team for having me here.
Thanks everybody for listening.
Bye.
Bye.